There are many ways to solve proportions, but in this video, let's look at how to solve proportions using equations. We know that cross products are equal in proportional relationships. What this tells us is that we can multiply across A times D has to equal B times C for a proportion. A times D would have to equal B times C. That's the cross products, and they have to be equal. Knowing this leads us to an equation. So if we are looking at a proportion, x over 5 equals 3 over 7, cross products, x times 7 is 7x, has to equal 5 times 3, which is 15. And if 7x has to equal 15, we can solve for x, isolate the variable by dividing both sides by 7. 7 divided by 7 is 1, and anything times 1 is itself, so x times 1 is x. And 15 divided by 7 is our solution. And we can write that as 15 over 7 in simplest fraction form, or we can think of that as 2 and 1/7. Sometimes you can solve your proportions with other strategies, but oftentimes an equation is the best strategy to use. In this example, we see that cross products are equal if you're multiplying all of x plus 3 times 4. You're going to have to use parentheses around any polynomial with more than one term to show that we have to apply the distributive property here because the 4 is being multiplied by all of that, the sum of x and 3. Same with 5. 5 is being multiplied by the difference of x and 2, so I have to use parentheses and apply the distributive property. When I distribute the 4 to each term in the parentheses, I get 4x plus 12. And when I distribute the 5 to each term in parentheses, I get 5x minus 10. Now to solve for x, I want to get my variables on one side of the equal sign so I can subtract 4x from both sides. That leaves me with 0. And 0 plus 12 is 12. 12 equals 1x minus 10. And we already know that 1x is the same thing as x because anything times 1 is itself. So now all I need to do is add 10 to both sides to get that x is equal to 22. So using an equation, I'm able to solve the proportion, find the value of x. 22 is what would make this a proportional relationship because 22 plus 3 is 25. 25 over 5 is equal to 20 over 4. Sometimes you'll see that negatives are involved, and if that's the case, you want to apply the negative to either the top or the bottom, but not both, because if you did that, a negative over a negative is a positive, and you're changing the value of that fraction. So what that means here is I can think of this as negative x minus 2. Again, the negative is applying to all of that, so make sure I put that in parentheses, over x plus 5 is equal to negative 3 over 10. So if I use my cross products and multiply negative x minus 2 times 10, so that's negative 10 times x minus 2 would equal to x plus 5 times negative 3, put the x plus 5 in parentheses so that I'm showing I'm going to distribute. Distribute negative 10 to each term inside the parentheses, negative 10x plus 20. It's a positive 20 because a negative times a negative is a positive. And then on this side, negative 3x minus 15. Get your variables to one side of the equal sign and your constant to the other side of the equal sign. So I can either add 10x or add 3x depending on which side I want my variable on. If I add 3x to both sides, that's moving the variables to the left and making it negative 7x. And then I can subtract 20 from both sides, moving my constant to the right, making it negative 35. And if I know that negative 7x has to equal negative 35, I can divide both sides by negative 7 to get x by itself. Therefore, x must equal 5. So the relationship is proportional when x is equal to 5. Negative 5 minus 2 is 3 over 5 plus 5 is 10. So that's how I would get negative 3/10 equals negative 3/10. So the solution is x equals 5.